Hi everyone, it's Alyssa and welcome to You Can Learn Math.
So today we're going to talk about sine, cosine, and tangent. This is a very introductory video, very introductory. We're just going to talk about what sine, cosine, and tangent are and do a very basic problem or two with them. We're not going to be doing problems that require inverse sine or cosine, just straight sine, cosine, or tangent. Okay, those will be for a future video. We will need that in a future video. So, okay. First, what is sine, cosine, and tangent? Well, you're going to see them abbreviated. Sine will be abbreviated as S-I-N. Cosine will be abbreviated as C-O-S. And tangent will be abbreviated as T-A-N. But you still pronounce them as sine, cosine, and tangent. Don't say sin, cos, tan. Still sine, cosine, and tangent. Now, all these are ratios. That's it. They are observed ratios that have been around for quite literally thousands of years. That have been observed for thousands of years. So these all have to do with right triangles and the ratios between the sides of right triangles. Now, if I have a right triangle, and this is not precise here, I'm just estimating, and let's say it had a 30-degree angle and a 60-degree angle. And let's say I had another right triangle that was also a 30-degree angle and a 60-degree angle. Now, if you've already had geometry, and I'm not sure if you have or not at this point, because sine, cosine, and tangent often rear their ugly heads first in algebra, and then you see them again in geometry, and then they come in full force with their friends in trig. So if you've already had geometry, then you may have come across similar angles and the whole angle similarity theorem. Similar angles are angles that have the same proportions. They have the same angles. They do not necessarily have the same sides. If they did, they'd be congruent. Similar just means like you could blow this, you could enlarge this, blow it up, enlarge this triangle and make the bigger triangle, or you could shrink this larger triangle and it would make this smaller triangle. So that's all it means when they're talking about similar. They would overlap each other. And I know I did not draw these perfectly similar, but you know, I'm not perfect, I admit it. So similar triangles have the same ratios. So it doesn't have to be a right triangle, but like say I had this triangle and I had another triangle that was similar to it, and its whiteboard's having a spaz attack. Come on, there we go. So let's say I have these two triangles and I'm told they're similar, and this side was 5 and that's 8, and this side is 10. What is this side? They're the same proportions. So 5 is to 8 as 10 is to this number. It would be 16. That idea of similar triangles having these same ratios, the same proportions every single time is the origin. That idea is sort of at the heart of sine, cosine, and tangent. Someone observed that. Actually, multiple someones observed that in several different cultures and started keeping a record of what these ratios are. So if I have a triangle and I'm going to look at, we have two angles here that are not the right angle. I'm going to call this angle A and I'm going to call this angle B. And then we have our three sides, which I'm going to call X, Y, and Z. So here are the ratios that they wrote down. As I said, if I have this angle A, what are the things I could do? I could measure all three sides of this triangle, and let's say I could divide that side by that. I could divide X by Y. That would be a ratio. I could divide X by Z. That would be a ratio. I could divide Z by Y. I could divide Y by X. All these different ratios. And so they did. And they have recorded them. Now, we don't have to use charts anymore. Your grandparents probably did, maybe even your parents if they were old enough that they might have had to use charts. Nowadays we use, most likely you're using your calculators. So here they are. Sine is opposite over hypotenuse. And we're going to break this down as to what each of these actually is. Cosine is adjacent over hypotenuse. And tangent, scoot that over, is opposite over adjacent. You know, opposite what? Hypotenuse, what is this? All right, that's our next step. Opposite and adjacent in this context, it's going to change depending on your perspective. Hypotenuse won't. Hypotenuse is always going to be the same side, but opposite and adjacent are going to change. So first, hypotenuse. Hypotenuse is always going to be the longest side, and that side is always going to be the one opposite the right angle. So it's over there, it's opposite the right angle, it's the longest side. That is always the hypotenuse. Opposite and adjacent are going to change depending on your perspective. Think about it like if I was sitting at a dinner table, and this is an overhead view, and here I am, I'm sitting down here, and I have my friend over here who's sitting on this side, and I have another person, another friend who's sitting over here, and I have another friend who's sitting over here. Okay, from my perspective, this person is adjacent to me, but this person is opposite me. But from her perspective, he is adjacent and he is opposite. So depending where we are on the table, it makes a difference as to whether the other person is opposite or adjacent to us. The same thing is going to happen here when we're talking about sine, cosine, and tangent, opposite and adjacent sides. That's what these are. So if I was talking about the sine of angle A, the opposite side divided by the hypotenuse, well, what would that be in this case? The sine of angle A. The opposite side, and I think I need to turn this, there we go, inked shapes off because it's kind of going crazy. The sine of angle A would be the opposite side divided by the hypotenuse, that ratio. So the opposite side is the one that's not touching it, the one it's looking at across the table. So that would be x. And then our other one, the hypotenuse, as I said, it never changes. It's always that longest side, the one opposite the right angle. So that's z. So if I wanted to know as a number what is the sine of this angle, I could take a ruler, I could measure the line x, that side x, that opposite side. I could measure the hypotenuse, the z side here in this picture, and I'd divide them. And that number that I got would be the ratio, that would be the sine of angle A. And I could look it up on a chart or use my calculator and go, hey, sure enough, the sine of this angle with this measure is that decimal. It would work. For the cosine of angle A, it is the adjacent side divided by the hypotenuse. From angle A's perspective, this y leg or side is adjacent to it. And again, the hypotenuse does not change. So the cosine of angle A would be the, let me change these to lowercase a so it's a little more accurate. There we go. So the adjacent side would be y, and our hypotenuse again would be z. And last but not least, the tangent of angle A would be opposite divided by adjacent. For angle A, the opposite side, the side it's looking at, the side on the other side of the table or triangle, is x, and its adjacent side, the one that's right next to it, is y. Now if I were to change these and say, I don't want the sine of angle A, or the cosine or the tangent of that, I want it of angle B. Well, it's very similar, but our perspective has shifted. So now it's no longer, let's get rid of this highlight, get rid of the whole triangle. Oh yeah, no half measures here. All right, so now we're doing Angle B. So from angle B's perspective, where is angle B looking? Who is adjacent to it? The leg that's adjacent to it, well, now it's X. X is what's adjacent to B. And Y is what's opposite. It's what it's looking at the other side of the table. It's what's opposite of B. So opposite over hypotenuse for B would be side Y, or the length of side Y, over the length of side Z. Cosine of B, adjacent over hypotenuse. X is adjacent, Z is still the hypotenuse. Tangent of B, opposite over adjacent. Y is opposite of it, and X is adjacent. So again, that adjacent and opposite depends on your perspective. Okay, now one thing I'd like to just say before I go and do an example of how you can actually use this to solve a problem, and tell you, you are likely in your book to see this given as a mnemonic device to kind of help you remember this. And I'll say SOHCAHTOA, and it's sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Personally, just that on its own wasn't a huge help for me, because I'm like, SOHCAHTOA, or is it SOHCAHTOA? I'm like, which one is it? This isn't helpful because there's no real clear indication as to whether the O or the comes first. So the way I remembered it is, to me, it reminded me of the historical figure Pocahontas and her name, because you have that O sound first, you have that K there in the middle, just like, SOHCAHTOA, and then the T comes last, and just kind of, I never had a problem with Toa. Toa, I got that. But the So and the K, I always kind of had a problem remembering, is it SOHCA or SAKO? Which one is it? But when I remembered that it was similar to the name, again, of the historical figure Pocahontas, then I said, or if you are a fan of the Disney cartoon Pocahontas based on the historical figure, if that helps you remember this, that's the connection I made, is that it was similar to her name, so that I remembered it that way. Whatever works best for you, there isn't a right or wrong here as far as how to remember this, just as long as you find a method that really gets these ratios ingrained in your brain so you don't have to worry about struggling to remember them on a test. Now, the most common way that we will use these is when they will provide you a bit of the triangle and ask you to figure out either an angle or a side. So for some problems, they will have you use what's called like an inverse sine, inverse cosine option on your calculator. We're not doing those problems. Those are where you're solving for the degree of the angle. This one we're going to solve for the length of a side. So this is the introductory problem. It's the most common one, the one you're going to see first. For example, if they said this angle is, let's say, 70 degrees, and this side is 6. How long is the hypotenuse? For these types of problems, always start by identifying which sides they've given you relative to the angle. So we have our angle here that is 70 degrees. What sides have they given us? Well, this side over here is the side that is opposite 70, the leg that is opposite. It's not touching it, it's on the other side of the table. It is the opposite leg. And they're also wanting us to find out, it's the other piece of this triangle that's involved, the hypotenuse, the longest side, the one that is opposite the 90 degrees. So it's the opposite and the hypotenuse. Which trigonometric function uses opposite and hypotenuse? We have a winner. It is sine. So that's the one you want to use. That's how you figure out whether you use sine, cosine, or tangent. You look at the problem, and the problem tells you which one to use. So for this one, the way you would set it up is you would say the sine of the angle, because we have the sine of the angle equals the length of the opposite side divided by the hypotenuse. Now we have two of those pieces. We know that the angle is 70 degrees, and we know the opposite side is 6 inches, 6 centimeters. I don't know, I didn't say. The hypotenuse we don't know, so we're going to call it x. Now this is really at this point a straightforward algebra problem that you will be able to solve using your calculator. So you're going to find out what the sine of 70 degrees is using your calculator. Depending on your calculator, if you have like a lower level calculator, like the app that comes with your phone, or just like a scientific calculator, you're likely to type in 70, then hit sine to get what the sine of 70 is. If you are using a graphing calculator, you're likely to put sine first and then 70. So just look, in your calculator's directions, or just play around with it a little bit and figure out what it is. So sine of 70, I type that in, and my calculator tells me it's 0.939. I'm going to stop there and round. 0.9397. Now, zoom out a little bit, move it over. Even though that's a lengthy decimal, this is not a very difficult algebra problem. Just use the same method you've already been using in algebra. So in this case, to solve for x, we want to get it out of that denominator. So first we're going to multiply both sides by x. So on the left side, I will then have 0.9397 times x equals 6. Then to undo and get x completely by itself, we need to divide by 0.9397 on both sides. A little unwieldy, I know, because of the because of that decimal with the sign. But once you do that, you will get that x is equal to 6.385, and always follow your teacher's lead or the test or the worksheet as to how many digits they would like that rounded to. Another example, I'm just going to do one more here to show you. So let's say that this was a little different. I'm not changing the triangle. I'm just going to change the numbers here. And I know that really wasn't a 70-degree triangle. Again, I'm just not good at drawing triangles. So this time I'm going to say these are not drawn to scale. And I'm going to say that this one is 42. I'm really going crazy here. So let's say it was 42 degrees, and they give you that the hypotenuse is 10, and they want to know what this side is. What do you use? Again, you always start by saying, what legs am I given? What sides am I given? What am I given? The hypotenuse, an adjacent leg, an opposite leg, relative to this angle. Since I'm looking at this angle, I know that 10 is the side opposite the 90 degree. It's the longest. It's the hypotenuse. And I'm also given this leg, which is touching the 42 degrees, so it's adjacent to it. I'm given the adjacent side and hypotenuse. That means cosine is our winner for this because it involves the adjacent side and the hypotenuse. So for this one, I would say, okay, I know the cosine of an angle is equal to the length of the adjacent side divided by the hypotenuse. I know my angle. My angle is 42 degrees. I do not know my adjacent side, calling it x, and I know that my hypotenuse is 10. At this point, again, it is just an exercise for your calculator. So you're going to type in and find out what the cosine of 42 degrees is using your calculator. And when you find out 0.7431, I usually keep it to 4 decimals. Follow your teacher's lead as to how many decimals they want you to use. So 0.7431 equals x over 10. Now this is a pretty straightforward algebra problem. X is being divided by 10, so to undo that, I want to multiply both sides by 10. So that gives me that x is equal to 7.431. So there you have it. Those are 2 examples of the sort of introductory problems you're going to get with sine, cosine, and tangent. I'm going to be having a few videos coming up shortly. I'm going to delve a little bit more into this. We're going to do problems where you have to figure out the angle based on the sides using inverse cosine. I'm going to go into the other additional trigonometric functions like cosecant, secant, cotangent, and also doing some trig identities. So stay tuned! Woo! Trig! Yeah, it's not my favorite either. All right. That's going to be it for today.
I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.